Hey guys! So today we are talking about a system of linear equations with two variables. That is section 1.2.1 is two variables with substitution. So the do now, when have you heard the word substitute used other than in math class? Go ahead and take about a minute to think about that on your own. Okay, some of the great examples that we had in class was a substitute on the basketball court or really any sport, sending someone in place of. But generally, we just wanted to have a conversation about substituting is putting something in place of, replacing something with a substitute. You replace your teacher with a substitute when they're sick. You replace a player when they're tired. So again, level one is to solve the system with two variables when one variable is a constant. So the first level is when the first variable is a constant. An example of that you can see right here where we have a equaling 4. Because a equals 4 and it's just a constant by itself, we can go ahead and skip forward. All we have to do is put a in to this expression at 3a. So we're going to have 3 times 4 minus, don't forget those parentheses to keep everything clean, 5b. We still don't know what b is, so we're going to leave it alone. It's just going to stay b for now. And that is going to equal 22. So go ahead and pause the video, practice your solving skills. Right here before we move on. So 3 times 4 is going to give me 12. Still minus 5b. We haven't changed that. And it's still equaling 22. Just like normal, I'm going to subtract 12 from both sides because the 12 is positive here. So we're going to have minus 12 over here and minus 12 from over here. Now remember, we do the opposite because we want to cancel something out. So then we're going to be left over with negative 5b on the left-hand side. And 22 minus 12 is just 10. So lastly, we don't really have room to show it, but we're just going to divide each side by divide each side by negative 5. We want to get b alone, so we don't want to divide by b. We want to divide by negative 5. So I'm going to go ahead and erase, and we'll have negative 5b equals 10. That's what we found. And so if I divide both sides by negative 5, my final answer is going to be b equals negative 2. Awesome. So our next example is actually a practice section. So I'm going to take about a 5-second break, but I want you to actually pause the video and take as long as you need to start working through these. And I'm just going to point out that here, each of these level 1 problems has a variable as a constant meaning an actual number itself. So y, the variable, equals 1, a, the variable, equals -4, and w, the variable, equals -2. So you can just plug them right in. So again, go ahead and pause that video and work through all 3 problems. All right, hopefully you worked through those yourself. You can see the answers down at the bottom there. Once I get through, I should go ahead and have the answer to both of my variables, x and y. We already had y. A we started with, but now we have b. W we started with, and now we have z. Awesome. So level 2 is going to be the same thing, solving a system of linear equations with 2 variables using substitution, so replacing things. But this is when a variable is already isolated. So the variable isn't as easy as just being a constant, but it is already by itself. So here you see that w is already by itself on the left-hand side of the equation. So it's not a constant. It's still kind of frustrating. We still have a variable on the right side, but we can still just plug straight in. So instead, up here where you see -6w, instead of writing just w, we're going to put this whole expression, 12 minus 2z. So we're going to see -6, don't forget your parentheses, 12 minus 2z close those parentheses, that's still -8z and equaling -44 on the other side. Oh, I ran out of space. All right. So the first thing we're gonna want to do is distribute this -6 to everything else in the parentheses. So -6 times 12 and -6 times -2z. So we should have -72, -6 times 12, minus, but because it's -6 times -2z, it's actually going to end up plus 12z. Ooh, got away from me. And we still, even though we finished up our parentheses, we still have -8z. And that equals -44 still. So now we need to combine our like terms. So if you look, we have 12z and -8z. Together, that's going to give us a positive 4z. And we've combined like terms on that both sides of the equation now. So -72 plus 4z equals -44. And now that we've gotten everything simplified on both sides, we can go ahead and start doing our normal solving. So we want to do the opposite of -72. So we want to add 72 to both sides because we're looking to get z by itself. So 72 is added to both sides. So on the left, we're going to be left with just 4z. And on the right, we should be left with 28, I think. Yes. All right, so I'm going to go ahead and clear off all that ink so I have space. But we're left with 4z equals 28, right? 72 minus 44. And lastly, we're going to divide by 4 on both sides because we want to get z by itself finally. So divide by 4, divide by 4. On the left, we have z equals, so 28 divided by 4, that's going to give me 7. That gives me 7. If z equals 7, I can now take that z that's all by itself as a constant and plug it back into our original fixed equation. Because we still want to find w. We don't have w by itself yet. So we have w equals 12 minus 2 times z, which we found to be 7. So 12 minus 14, w should equal -2. So don't forget, if you have a variable in an expression but not as a constant, you still have to go back and find that variable. All right. So go ahead and take some time to practice this on your own. Make sure that you're getting all the way through all 3 of them. I'm going to give us about 5 seconds before I move on. Okay, hopefully you did that work and pause the video. We see that here are all of our answers. And we can move on to level 3 in the next video. But before we leave, I want you to write down, what is the most confusing thing about substitution? What are you stuck on? What questions do you still have? And go ahead and bring those back to me when you see me next in class. But otherwise, have a wonderful day. See you around.